Hello everyone, I'm Michael Johnson. Uh, Together with me, I have today,
Martin Anderson. Hello, everybody.
so there you have our sound checks. Welcome everyone to this approximately 1 hour presentation of unit testing with Cantata. I'd like to start with asking you to, if you wish to ask questions, please use the chat functionality as chat window, and you can send your message to the presenter or to everyone. We will have the mics muted for most of you guys. So welcome. Unit testing, and particular with Cantata. Unit testing is something which is becoming more and more important as we do more and more complex software. And if you're going to do serious unit testing, you're probably going to spend as much time developing tests and running tests as you are developing your code. So that's why we have made this presentation about Cantata, because it's a commercial tool. It has a price tag, but we show you how it can help you do your tests much easier and much faster. We've been working with Cantata for about 20 years. The product's been on the market for a bit longer than that, and it's used by hundreds and thousands of customers around the world, and we have a lot of customers in Scandinavia as well. We like it very much. It's a nice product, and it's working well in all kinds of environments, from 8-bit to 64-bit applications. It works also, sorry, early morning yet. It's a work. Let's look at the agenda today. Yeah, we will talk about unit and a little bit about integration test and what we mean with that. It has some different meanings for different people, so we will clarify that. We will then show you how you can generate your test scripts in an easy way with Cantata, and see how the functionality of measuring test efficiency through code coverage works. Because that's the crucial thing with testing, is to know when to stop testing. When have I done enough testing? When am I done? And how do we measure that? And the most common thing to use is some type of coverage, test coverage measurement on your code. And of course, you probably will have to report your results in some way, particularly if you're doing safety critical or security critical applications, which is what a large number of our customers do today. If you do such things, you will also need to have traceability. You have to be able to link your requirements to your design, to your code, and to your tests. And we'll show you how Cantata can help you with that. And of course, in the long run, you run your tests over and over again. You will want to automate it. And for instance, use a CI engine like Jenkins is a good way. And we'll show you how you can reuse your tests and run them over and over again as regression tests. So where does unit test fit in, and what do we mean with unit testing? Well, looking at the development cycle, let's say you have produced your code. The first thing you do is, of course, to see that it compiles. The second thing you do is really to check whether you have robust code enough. Make sure that you don't have any obvious structural problems in your code. And that's what you do with static code analysis. You check your code. We work with Code Sonar and PC-Lints as tools for static code analysis. It's a cheap and fast way of creating robust code. So you check in your robust code when you scan it and it passes. And the next thing you really want to do is to check the functionality of your code. Does it do what we want it to do? And now we're coming to the unit testing. And with unit testing, we mean testing the lower building blocks of your code. Things like functions, methods, classes, modules, and this is where Cantata comes in. Also testing in larger blocks and together with your target. That's what we call integration test, to make sure that the functions and classes and methods works on your target as well.
Yeah, exactly. And actually, as sooner or earlier you can detect any defects or any problems with your code, it's cheaper it is. And that's one of the reasons why you should use unit tests.
That's what I say.
Exactly.
So fix your problems early. That's what we're warming for. So, and then we come to that critical question: when have I tested enough? Because really, we can go on forever testing. There's so many ways of testing, and there's so many possibilities. So the best way to do a check on when we are finished is to say, have we passed some kind of standard for code coverage? So when we run our tests, how much code has it covered? Has it covered all statements? Has it taken all branches in our code? Has it used every type of variant of branches? So these are things you can establish to say, I want my tests to cover at least 50% of all my statements, or 100% of all my statements. But you set the limit, and that should be the same limit for the whole project usually. So everyone uses the same standard to test against. And the cool thing with Cantata, compared to many other solutions, is that the code coverage measurement is built into the tool. So when you run a test report, you will get the report also on the coverage you have had during the test execution. And of course, if you want to continue testing, you move on to system testing, where we have tools from know-how like SexApp and MX Suite to do complete system testing, model-based testing, etc., hardware in the loop testing. But that's not on the agenda today. I mentioned that a lot of our customers have to follow safety critical standards or security critical standards, like in the automotive, like with airborne equipment, medical equipment, etc. So if you who listen use one of those standards, it's good to know that Cantata has been certified to be appropriate for use in such applications to the highest safety level standard. And there are qualification kits that you can use to easily prove that Cantata is suitable in your project. Yes. I think that's about it. Let's look at a little bit of the features of Cantata before we move on to a live demo. I know you will want to do the live demo, Martin.
Yes, of course. I'm eager to get started. But let's do some more slides before that. Well, the tool integration. Cantata is built up with Eclipse, and it's built up with makefiles, and the graphical user interface is Eclipse. And there are plugins to the Jenkins, together with something that's called team reporting. Team reporting is a functionality we'll talk a bit about later on. It's about working better together. And with the built up with the makefiles, it's very easy to integrate it with your developed environment. The good thing with Cantata is that you have a automatic generation of your testing framework. It's easily set up, you have a graphical overview, and in the same time, there's nothing magic. You can still go in and use your text editor to do your test scripts and run your tests. It's easy to control what calls are made from the software that's under test. I mean, if you're calling malloc, if you're calling string length, or if you're calling something else like a CAN bus or something, you can control the behavior of that call. And there's a graphical view to do that also. You can do different instances of these calls. I will talk a bit more about that later on, how that works, but it's a good feature.
What do you mean when you say control the behavior?
Well, by controlling behavior, you can actually control exactly if you want to add something to that call, to the function that your software under test is actually doing, and you want to alter the behavior of that function, what it's returning. I will show you a bit later on. I have some slides on that also. The most common thing is you do like a stub or simulation, isolates, different name, same thing, where you can't have the stub or the called object inside of your build. You have to create the stub for that call object. You can check the parameters, check your call order, etc. You can use choose the return parameters as you want to. But with the unique feature of Cantata wrappers, you still have the called object within your build, but you can control the behavior of it. This is like the wrapper. You have the wrapper, you can check the parameters to the function that you're calling, checking the order which you're calling the functions. You can modify the parameters that's sent to that object that you're calling, and you can check the parameters coming from that object to have a checker if you want to. And of course, you can modify the parameters from that called object.
Could you give me an example on when that's useful?
Yeah, of course. If you have something like hardware queue or something else that's very hard to actually introduce errors to, I mean, something that's really hard to test, then you can have this function like a CAN bus or communication queue or something else that you're calling that's really tricky to replace by doing your own dummy or your own stuff. Then you can use this wrapper function. You can alter behavior from it. I will do a simple but stupid demo of it later on, so you will see how it works.
Okay.
The other function also is with the wrapper, you can of course replace it completely as you do with the stub. When you build up your test script together with your software under test, and I mean, this is your software under test, and here you have your test scripts that you're developing, and then you want to run the test to check that everything works out fine. You build it together with Cantata and its library and the compiler that you are using, the build chain that you are using. It could be GCC, or it could be ARM, or it could be something else. It doesn't matter. You build an executable that you then later on run on the target or on the host, depending on what you want to do. And all of this is built up with makefiles. That makes it easier to integrate with your build environment. When you have run that executable, you get the result out from that, and you get a number of different views of the result from that, making it easier for you to do progress on your different unit tests. I will show you that also a bit later on. When you're developing your executable, you normally do that on your host, and you download it through the connection that you have to your target, if you want to run it on target. And then you have different possibilities to get out the result from that executable. It depends on what option you have. Let's say you have a JTAG, for example. Then you can download it, start the execution of that binary on your target, but perhaps you don't have any file output or something like that. Then you store the result on the target and you lift it out to analyze it later on, and then refine your tests or make a new test, etc. So this is the normal way of doing it.
But if I wish, I could also test on my host, couldn't I?
Yeah, of course, of course. You can test on your host if you want to, or do it in a simulator if you want to. It doesn't really matter. It depends on what build chain or build tool you have.
Okay, but would I need to do a lot of changes on my test scripts?
No. The environment and the look and feel is exactly the same. So you just build a test, run it wherever you want to. The other thing I just mentioned before is the team reporting. It's for like project manager that wants to have a overlook of what the progress of the different tests is right now. Then they have a server functionality. It's an add-on where you can actually drill down, see how the overall progress is for different projects. Then you can actually drill down to each of these different source files to see how much code coverage, how the unit test is progressing, etc. Together with the team reporting, you have the plugin for Jenkins where you automate your tests. Let's say you want to reuse your tests over and over again, then Jenkins is the perfect way of doing that. You can rebuild them over and over again, checking that you haven't broken anything or see how the progress is going on. To create good unit tests, what do you need?
Well, you need a good software requirement specification, I guess.
Yes, exactly.
Because you need to build good code, right?
Exactly. To do good unit tests, you actually need good requirements. And by having good requirements, it's easier to implement your actual source. And after that, it's much easier to check that you actually fulfill all the requirements that you have. And by having good requirements and having the unit test created in Cantata, you get a good trace, a good link between the different tests you created and the requirements that you have. And you can export them back to your requirements tool afterwards.
Yeah, I know this is an important feature for most people that have traceability requirements in their projects.
Yeah, many of those have different requirement tools that have developed their requirements, and then they want to really check that each of those requirements is fulfilled. And that's easily done with Cantata. You can connect the different requirements to the unit tests. I will show you in the demo. So let's get started. Just starting up Cantata, hold on. I think you should be able to see it now. Yeah?
Yeah.
Okay, so here we have the graphical interface. It's Eclipse. I have a project here that's very simple. It's a reverse string. Let me just open it for you. You can see how it looks like.
So what does it do?
The function takes a string of characters and puts it out in reverse order. So it's a very simple and nice function. That's it. And now, of course, there's the header file, nothing in it, more or less. But this is the function that we want to create tests for. Okay, so how should we get started?
That's what I'm asking you.
Yeah, with Cantata, it's very easy, actually. You can just select the source file you want to create a test for, and then you can generate test script. And Cantata will generate the test script for you depending on how you want to use it. You can either have it as a test case per function, auto test. You can select the name of the test script, and you can select what level of code coverage you have or what standard you want to use. I'm just going to pick one. We can have a look at that later on. Okay, let's click next. Cantata has discovered for us that the function that's under test is calling two other functions. It's calling malloc and string length. And it has suggested that we should use wrapper as controllet. We could, of course, try to exclude malloc and string length from my mingv GCC library, but in this case, and do a stub, but in this case, I want to have them and call the actual function and do a wrapper on them later on to show you how it works. So let's finish. Let's have a look. What's happened here? we get a graphical interface helping you setting up different tests. And this is just a summary, my code coverage. I have the test cases. It's created the first test case for me automatically. Let's have a look at the details for that test case. It's called test reverse string length, malloc. Okay, good. What's the other tab? That's a control, interface control. There is where you can control the calls made from your software under test. I will show you a bit about that later on, but for now you can just scroll by it. You can initialize global data, but we don't have any, so we'll keep it simple right now. Okay, so let's run this test, see how it goes. Just make this a larger screen here. Okay, so we get a short summary output, but let's have a look up here. We're actually using we're actually using a GCC compiler from my MinGV library in the default installation from Cantata, together with a Cantata listener. So it listens what happened with the build, and then it knows how the source file looks like and how it should work. Okay, so the short output here in the console shows me that my test case checked, passed, but my coverage rule set failed in one instance and passed in one instance. And the overall test result is a fail. Okay, so that's the console output. We have some other views. We can have a look at, for example, the test result explorer. Here we have my test case, this one here. And we can see it's calling, starting a call sequence, string length, and return value. It checks what it's put in and what it's put out. It's null and null out. And then we have my coverage rule set. We can see one entry point coverage is covered, but the call return coverage is not.
That's because it's red, right?
Yeah, exactly. Good. There are colors marking up how the progress is going, good or bad. Okay. But as we talked before, to do good unit test, we need requirements. Let me see here. Where did my mouse go? There it is. Okay. So let's import the requirements that I have. Oops, there are already some important requirements. It's because I've done the run over this demo just prior to this webinar. Anyway, these are the requirements I have. It's an Excel sheet. You can see here I have one general requirement, and that's code coverage rules, and I have two test cases, more or less. One when input string is null and the character null shall be returned. Okay. And the second one is when my input string is not null, and it should be outputted in the reverse order. Okay. Unfortunately, these are already imported, but just to let me show you how it works, I go to import. I can select different types of inputs, text, Excel, recif, and recif is an XML format that's used from a large number of different requirement tools.
Like Polarian,
Doors, PTC, yeah, a lot of different. But for now, let's select Excel. Let's find the file. I have a demo here, a reverse string, low level requirements. Open that. Selected the correct worksheet, import complete. I have the three requirements that I have here. I select them all. And then I go to the tab that's called requirement trace, because now I want to connect the test case that's auto-generated. I haven't written anything yet, to the different requirements. And I know that the first test case is actually doing one of the requirements that I have. Null is put in and null should be returned. So that's okay. Let's connect those two. And then we have the general code coverage. Yeah, that it's probably not the correct coverage I've selected. So let's just select the correct one. It should be entry point, statement, calls, decisions. Okay, save that. Let's rerun it. And we will connect the general requirement to the general setup for my unit tests. And you can see here, when it's finished, you have some more requirements I have to fulfill. And in my trace, I will take my general test script and connect it to the general requirements that I have. Okay, that's good, almost. It's red. The coverage is not fulfilled yet. So let's see what coverage do I need.
Well, you probably need to make some more test cases, right?
Yeah, probably. But to see what I'm missing, we could have a look in another view. And it will point me to the first issue that it have with the coverage. And it's actually in this reverse string. Let's enhance this a bit. It's easier to see. You can see here, this is my function. I only have one function in the software under test. And if the original string is not null, okay, I haven't tested that. So I have to put in something to that. And you can see the green marked source is exercised and the red is not. Blue is comment. Okay, so let's generate another test case. We go into test cases, take the first one that's auto-generated, copy that one. And if we go down to the test case editor, we can go in and change. You can see I have this test case here, test_1, test reverse string _1, and I want to change the input value to that one to something else. Let's just put in some text like that. And let's save it. And let's run it once more. So now I created two tests. And let's see how much of the coverage I will fulfill now. Oh, great. It actually covered all of my coverage rule set. So I have here the test and the test cases, and I have one requirement I haven't fulfilled yet. So let's connect that one to that requirement. Good. So now I've fulfilled all the requirements that we had. That's great. And I have fulfilled my coverage. That's also great. And I've done two test cases, done the requirements with very little effort. To show you one of the functions that we talked about later, let me just show you the wrapper functionality. I'm going to demonstrate that on the string length function that's called from my software under test, so you can see how it actually is working. So let's go back to Cantata, and just let me copy the last one, copy another one. So now these are two exactly the same test scripts. And let's I can also show you one more thing that I've forgotten. I haven't shown you the actual test script. Let me just show you that. You can just put this up in a larger window. And I can put these two side by side. So you can see there's nothing magic behind this graphical user interface. It's just more or less pointing me to the direction where it is. So if I change something in here, like this one here, sorry, I'll just do that. Oops. Sorry for jumping back and forth. Just putting it up so it's easier for you to see it. Let me just, like if we have a look at this one there, and change that, and we save it, and you should see it here. Well, it's updated on both places.
So the test scripts are written in C.
Yeah, exactly. So depending on the software on the test, If you're written in C, your test script will be in C. If it's written in C++, it will be in C++. So it's very easy to get familiar with the test cases, how it's built up. Okay.
Can I modify my tests in the C language if I wish?
Of course. You can do everything that you normally do in your C and C++, and you can change the test script, develop the test scripts, everything. So it's up to you where you want to work.
So if I want to reuse a test case, I could modify it in the C code, and I don't have to go through the GUI here.
Exactly. So nothing magic with the GUI. Okay, where were I? I'm going to do a wrapper. So let's have a look at the different calls that's made. We have, let me enhance this one so it gets a little bit larger. We have the calls that's made from the software and the test. It's string length and malloc. And each of these instances have one instance default. And let's just add a stupid function here. Something like this. No checks. And I have the before after or the before replace wrapper functionality. Let's select the before after. Click OK. And you can see now that my malloc just has the default instance, and that means it will call and use the malloc without any changes. But for my string length, you can see there are two instances of it now. So I can create a number of instances depending on how I want to alter the behavior of that called object from my software on the test. Okay, for now it's still the same as the default, but just let me add something. It will put out the wrong length from that instance. And let's go to the test cases. And in the test reverse string, I want to change instead of default, I'm going to use the wrong length instance of string length. So let's save that. I can just show you here in the details. You can see there are difference between them. I'm just putting that down there. Get the details up. It's easier to see there. You can say default, and if we go to the other test case, it's wrong length. So now I'm calling a new instance of string length that's called wrong length, and I've added one in the size it returns. Okay, so let's just run this reverse string. You will see there will be another test case added here in Test Result Explorer. And you can see here it's red. You can actually go in and see this test case here, the test value, what its actual data is also. You can go in and have a look at that. You can see it's expecting the test in reverse order, but it gets something else, so it fails. Okay. So very little amount of work to create 3 test cases and one which demonstrates the wrapper functionality. Yeah, and I can show you the team reporting, how that looks like. Let me just see. I have a Cantata server running in the background and set up to, when I've done this project for you during this demo, it's uploading the results to the server. And this would be the look that the project manager would have. We'll go into the reverse string that I have here. You can see it created and run. And we can actually go in and run or see how the test is progressing, and you get the same look and feel and view as you have inside of the actual GUI. You can see my demo of the wrapper functionality. You can see the data. You can go down and see the coverage for the function that we are testing. You can have a look down into the source also.
So this is a good tool if you're a project manager and you have several projects and you want to monitor progress, I guess.
Yeah, exactly. Or if you have teams over different places or different parts of the world, you have to have a good look and feel how the progress is going with the different unit tests. So this is a good way of doing it. Let me see, what's there something else? No, I think we're quite finished with this part. Just to show you another functionality, it's very easy to set up. Let me just close this one. What if you have some old code?
Yeah, I mean, most projects don't start from complete scratch. Most of my customers have a lot of legacy code. And I usually tell them not to bother to do much unit testing on the old code because you know it's working. But if I still have a requirement that I need to do unit testing in a new project,
Exactly.
well, how do I solve that?
Yeah, how do you solve that? That's a good question, really good question. Well, as Mikael just said, it's probably not worthwhile doing unique test cases for all of them manually. But with Cantata, it's easy to set up unit tests that exercise as much as possible with the code coverage rule you've set up, that will create tests that pass. I mean, if you add something to that legacy code and you want to check that you haven't broken anything, then you can reuse these tests that's created automatically from Cantata to check that you haven't broken anything in your legacy code. So here we have the reverse string function again, a new project. Let's just pretend this is our legacy code. Very complicated, a lot of functions. Well, not really, but just to see how easy it is, there is a one-click auto test. Just click that. We don't want to upload it, and it will automatically build, create tests, do everything for you to get the exercise of that legacy code done with a number of tests. So now it's actually created a number of tests, and it's actually showing an example of how a test report also could look like. But let's just make that a bit smaller, and you can see it's generated 3 test cases for you automatically for that reverse string function.
So how does it know how many test cases it must do?
It tries to exercise all of the if switch statements that's available and try to reach the highest possible code coverage it can.
Okay.
So it doesn't really do any real test cases, so to say. It just creates tests to try to exercise the code. That will always pass.
Okay. So can I use this to find dead code, for instance? Code that cannot be reached?
Yeah, you could. You could. So this is one way of using the auto test. And you can see here there's one example of test reports. The test reports can be in text, HTML, ready for authorization for different requirements, depending on what needs you have. That's auto test. There are a lot of other functionalities in Cantata, like table-driven tests, creating different value ranges, performance measurements, etc. So a lot of different other features within Cantata. Like
Can I measure timing in Cantata?
Yeah, you have one possibility to actually measure timing in Cantata, but yeah, I want to demonstrate it now. It takes a bit more time and another project to show it on.
Okay, so now I've created my test and I spent a lot of time doing that, and I want to reuse my tests.
Yeah, exactly. Then you will probably need a tool like Jenkins to continuous integration or something like that to get them automated run or nightly built, or how you set it up more or less. We have a server here at Know-How showing off, let's see, I've been disconnected. Let's try to connect again. I'm just connecting to the server. Or not. Let me see. If it's up and running. Let me see here if you can see it. I will try to make it a larger screen. Or smaller. So this is just a quick view of how the setup is on our server, where we have Jenkins triggering Cantata on the target, doing the tests, and a number of other things also, and reporting back to Jenkins how it went. Just here, if I can make this a bit larger here. So this is one of the build steps within Jenkins. And you can see here, I run this a number of times, and you get the report from Cantata to Jenkins. Let me just see if I can, find the back button here. Oh, sorry for that. Back to reverse string, project, and you can get the quick output if it's a success or fail. And you get the link to go inside of the team reporting server that's also running on our server, and you get the execute or the result from that test in the same way that I showed you, but on my machine it was a local host. So there is a plugin for Jenkins to easily integrate it to your build system. Let me just see where have I missed something now? I don't think so.
Let's see if we have any questions. Please use the chat window to send questions to.
Let me see.
To us.
There was some. There is one here I can take. Is code coverage measurement dependent on the compiler? Can it work on the target hardware? No, it's not dependent on the compiler. It's instrumented in the code. And yes, it works on the target. That's one of the key features with Cantata. Let me see if there is something more that can show you. Show me one of the auto-generated test cases. Of course, I can do that. Well, it's not very easy to read the auto-generated test cases, but here we have one. The first one is actually the same that's auto-generated when I do the demo for you, and it's just putting in null and expecting null, more or less. So it generates different test cases to exercise different parts of the code. Let's see here. Created to solve true case of original string not equals null. So sometimes it's not very easy to understand the auto-generated test cases. But just some examples. Let me see if there's something else. The exact difference between the stub and the wrapper. Well, the stub, you have to create the actual function within the stub yourself. With the wrapper, you can still use the function you're calling, and you don't have to alter it if you don't want to, but you still have the possibility to alter it when needed. For example, if you're having communication queues or some hardware that it's not very easy to do a stub for, then you can use the wrapper to calling that real hardware, and you can change the behavior of that. Let me see. There is a lot of questions. Perhaps
I had one question here. Can Cantata do formal verification and or symbolic execution of functions?
Oh,
But formal verification is not part of Cantata.
no. There's one here. Can I execute test cases created in Cantata without Cantata? You can run the binary because that's a compiled binary. So you can run that on your target, on your host, wherever you want to. It's like an executable or yeah, depending on how your compiler or tool setup is done. But to analyze it, then you need a license.
You mean analyze
the result from
results?
it. Yeah. To get the graphical views, etc., etc. You need some license to do that.
Another question: how well does Cantata work in test-driven development? Well, that's exactly what we're talking about: test-driven development. Define your tests early and start executing as early as possible. So, of course, to run Cantata, you need the code. Otherwise, you don't have anything to test on. But unit testing is an important part of test-driven development. We had another question: is it possible to get test cases generated without using the Eclipse?
Yes.
So you don't have to use Eclipse.
I mean, you have to either copy or write the test cases, but you don't need Eclipse for doing it, more or less. I mean, the graphical view of Eclipse is just a graphical view. You can still put up your text editor you normally want to use and create the test cases in there instead, and then build them, compile them.
If I'm using Microsoft Visual Studio?
Yes, of course, you can use that. But you have to use the Cantata macros or functions. And there is some question about how it handles global variables and static variables inside. Perhaps I can do that in another webinar, setting up some nice examples. But it's no problem to do that. There are functions within Cantata library to handle exactly global variables or static variables inside of functions, etc. And there's one question I'm not really sure. Perhaps I can have a look at that later on. Is there some more questions? Yes, and there's one. Sorry. Can the wrapper record calls? Example: I want my unit to call foo and bar once. Yes, it can. It can't record, but it can check that the execution has been done in a certain way. So if it passes that check, I mean, if you want to have foo called first and then bar, or bar again, etc., you can set that up as a check for you. So yes.
Okay, that seems to be the questions so far.
Yeah.
I would like to point out that we have recorded this webinar and we will put it on our web. We'll send you a link to it if you want to share it with other members of your team. And if you're interested in testing, trying out Cantata, we will be more than happy to help you. Just send us an email and we'll help you with the setup and get you the evaluation licenses.
Yeah, exactly. So shortly, just to summarize it up, just the requirements, traceability, links between the tests and the requirements. You get a team reporting, centralized, integration to Jenkins. I think that's about all we have to show today.
Good, Martin. We say thank you for listening, and welcome to contact us, and have a really good day today.
Thank you all for listening in. Bye bye.
Bye now.